Hi, I'm Paul Kogan from GK Tuition, and in this video I want to talk to you about algebra. Now the question I've chosen to go through here is 2019 Paper 1 Question 2, and here I'm going to look at Part A. In this question we're given a graph, and the graph of f of x, which is equal to 3 to the power of x, has already been drawn. And we're asked to draw the line g of x is equal to 4x plus 1. Now, I think it's important here, if you're trying to find coordinates, you should make it as clear as possible to your examiner. So I've subbed in g of 0, and I worked out that one of the coordinates is 0, 1. I subbed in 0.5, I subbed in 1, I subbed in 1.5, 2, and 2.5. I think it's just a good idea to do a bit of work there, and you write out each of your coordinates. So you write out each of your coordinates, and you draw your graph, which should obviously just be a straight line. In the second part of this question, we're asked to use substitution to show that f of x is less than g of x when x is equal to 1.9. So in other words, mathematically we could write that as we need to prove that f of 1.9 is less than g of 1.9. The function for f of x is 3 to the power of x, so f of 1.9 will be 3 to the power of 1.9. The function for g of x is 4x plus 1, so g of 1.9 will be 4 times 1.9 plus 1. And we can simply just plug these into our calculator. The left hand side becomes 8.0636 and the right hand side becomes 8.6. Clearly this number is bigger than this number, so happy days. I can just put a tick beside it and say that it's true. If you're asked to verify something or anything like that, it's very important you do a little conclusion, tick it, show that it's true, rather than just stop it. You need to make a conclusion in a question like that. In part B of this question, we're asked to use induction to prove that f of n is greater than g of n when n is greater than or equal to 2. So the first thing you should do is write out the actual maths. So f of n greater than g of n means that 3 to the power of n is greater than or equal to 4n plus 1, and I need to prove that this is true by induction when n is greater than or equal to 2. So obviously your first step is you're going to test for n equals 2, or you could just write that as p of 2. So I'm starting off at 2 because I'm only trying to prove it for once it's greater than or equal to 2. I just sub in on the left, sub in on the right, and I end up with 9 is greater than or equal to 9. Clearly that's true, so I'm happy enough with it. The second thing we need to do is we need to assume that it's true for n is equal to k. And another way of writing that is just p of k. So to assume it's true for n equals k, we're basically just rewriting the top line. Just everywhere there's an n, we're putting in a k. And I put a big, I've highlighted it here because I know that in order to finish this question, I need to get back to this stage. So from now on, I'm going to assume that this is true. So really the first two steps in your induction are straightforward enough. It's the next step that we have to do the maths. Okay, this third step is the one that often catches a lot of people out. The third step is we need to consider n equals k plus 1. And another way of writing that is you can just write p of k plus 1. Okay? So what I did is I went to my original inequality, and instead of an n, I subbed in k plus 1. So now I just need to simplify this down. And when you're simplifying it, you should always bear your assumption in mind. I'm going to need to use my assumption before I get to the end of this step. So the first thing I need to do is split up the left-hand side, which is 3 to the power of k plus 1. Now you should realize that I can use the first rule of powers to simplify that. The first rule of powers in your maths tables on page 21 is that a to the power of p plus q is the same as a to the power of p multiplied by a to the power of q. With that in mind, I can simplify 3 to the power of k plus 1. That's like the left hand side of this, and I can just move to the right. So 3 to the power of k plus 1 is the same as 3 to the power of k multiplied by 3 to the power of 1. And if all I can do on the right is multiply out my brackets. 4 times k plus 1 is 4k plus 4, and then I've got a plus 1 at the end. Now, there's one term on the left and 3 terms on the right. That's causing me a problem. If there's more than one term on the right hand side, I need to have more than one term on the left hand side. So I need to split this term up. So this is 3 to the power of k times 3 to the power of 1. Let's just write that the other way around. 3 to the power of 1 times 3 to the power of k. It's the same thing, but it's just easier for us to view it like this. Obviously 3 to the power of 1 is just 3. Now this is the step that often confuses people. I want you to view the left hand side there as if it's just 3x. And if I had a 3x and I wanted to split it up, I could rewrite 3x as 2x plus 1x. 3x is the same as 2x plus 1x. I'm going to use that logic to split this up. That means that 3 times 3 to the power of k is the same as 2 times 3 to the power of k plus 1 times 3 to the power of k. I have 2 of them here, 2 times this plus 1 times this. If I added them together, I'd get 3 times that. So it's the same thing, I'm just writing it in a different format. Now obviously 1 times 3 to the power of k, I don't actually need to put in the 1. The reason I want to do this is because look at what I have in my assumption. In my assumption, the left hand side is just at 3 to the power of k. It's just 3 to the power of k on its own. So at least now, this bit here, the second term I have on the left, that's coming from my assumption. And then on the right hand side, I want to just rewrite it so that I've got a 4k plus 1 beside each other. So I can just rewrite this as 4k plus 1 plus 4. I'm just writing things in different orders. And now I'm happy out, now I'm able to prove it. I'm trying to prove that the left hand side is greater than the right hand side. Well, let's just do this. We can do it piece by piece. First of all, the first thing you go to is your assumption. I know that 3 to the power of k is greater than 4k plus 1. So that's the first thing I would say. I would say that 3 to the power of k is greater than 4k plus 1. Now, obviously, I need to justify that. My justification is that from my assumption. I'm working off the assumption that that's true. So from assumption is sufficient to explain what you're doing there. Obviously, I can't just ignore the other terms. So I have to accommodate for the other terms as well. The other term on the left-hand side is 2 multiplied by 3 to the power of k. The other term on the right-hand side is 4. So I need to know, is 2 times 3 to the power of k greater than 4? Now think about this. I'm trying to prove this. The smallest number I'm trying to prove this for is 2. The smallest number I'm trying to prove this for is for n is equal to 2. If you subbed in n equals 2 here, you would get 3 to the power of 2, which is 9, and then you'd multiply it by 2, which is 18. So happy days. You don't even have to sub it in. You can just say that this one is clearly true. It's true for any values of n is greater than or equal to 2. It's true for n is greater than or equal to 2, and that's all I was trying to prove. So if this bit on the left is bigger than the first 2 terms on the right, and the first term on the left is bigger than the last term on the right, clearly I can say that the whole left-hand side is bigger than the whole right-hand side. So that's all the maths I need to do. My fourth step now, I just need to make my conclusion. So your conclusion is more or less always the same. I can now say the proposition is true for n equals k plus 1 if it is true for n equals k. But I proved that it is true for n equals 2, so therefore it must be true for 3, for 4, for 5, for 6, for 7, and so on, for all the values for n is greater than or equal to 2 and n is a natural number. So I hope this video makes sense. If there's anything you're struggling with there, make sure you let me know in class or send me an email and I'll try and clarify it for you, or I'll try and explain it differently.